Hey guys, Ms. Zarnowski back here for skills check retake for 8.3, 8.4. This time we're looking at question R2. It has to deal with some radical equations. So there are a lot of words here. You gotta make sure you read them, and I would always underline or circle any important information from the text as you're reading it. So it says that the velocity of the water that flows from an opening at the base of a tank depends on the height of the water above the opening. The function v equals the square root of 2 times g times h models the velocity in feet per second, where g, the acceleration due to gravity in feet per second squared, is about 32 feet per second squared. So this is g. X is the height in feet of the water. If the water flowing from the tank with a velocity of 40 feet per second squared, what is the height of the water above the opening? So the first thing I'm going to do is I'm going to write down the equation that they give us in the problem. Velocity equals the square root of g2 times g times h. And now I'm going to plug in all the information they give me. So they tell me velocity is 40, so that goes in for v. They also tell me that g, the acceleration due to gravity, is 32. So I'm going to put 32 here, and we're solving for h. So now we have to do a little bit of simplifying. So I get 40 equals 2 times 32 is 64. And now we have that h underneath the square root. So what I'm going to do is, in order to get rid of that square root, I'm going to square it. And if I square one side, then I have to square both sides. So when I do that, 40 squared is 1600. Here, square root and square cancel each other out. So I get 64h. And now what I'm going to do to solve for h is divide both sides by 64. And when you use your calculator and take 1600 and divide it by 64, you will get that h, your height, is 25 feet. And that's it. That's all you have to do for this problem. Make sure you substitute information in and solve correctly.